when the cost of capital is time varying and we have a sequence of cost of capital R1, R2, Rn, we have seen that the AIRR, the project's rate of return, is computable as present value of incomes divided by present value of capital times 1 plus the first period cost of capital. And we also have seen that we can compute the overall cost of capital. We have also called it minimum attractive rate of return in the same way, but we replace the project's income with the market returns that would be earned if the same capital amounts were invested in the market. Now there is a second way we can compute the overall cost of capital, and it makes use of the relation between the project rate of return and the net present value. We have seen that the net present value is equal to the total capital invested, which multiplies the project rates of return minus the minimum attractive rate of return, or overall CAC, overall COC, divided by 1 plus the first period cost of capital. Now, from this relation, we can reverse engineer the relation and find the cost of capital, the minimum attractive rate of return. Now it's rather simple. Just make the simple passages. We multiply by 1 plus R of 1, and we get this product structure. Then we may divide. So this is not a very nice parenthesis. So let us make it again. Okay, and we divide it. We divide both sides by the total capital, and we have NPV divided by the present value of total capital times the conversion factor. And this is the excess AIRR, the excess rate of return. And then we find the cost of capital, or minimum attractive rate of return. We can use either expression. And we have project rate of return, and we subtract the NPV divided by the total capital converted to annual index. And so we have a second way to compute the minimum attractive rate of return. Once we have computed the project's rate of return, we can simply compute the minimum attractive rate of returns starting from the NPV. So we have two equivalent ways. The first one uses market returns, and the second one uses the NPV and the project rate of return. In terms of our example, now let us apply this formula. We have that the minimum attractive rate of return, or overall cost of capital, is equal to the project rate of return. We computed it, and it was 57.8%. Then we subtract the NPV. The NPV is 318.1 divided by the total capital. Total capital is 947.8. We multiply by 1 plus 15%, and we get back the overall cost of capital, which is 19.2%. Note that the latter relation is not circular. That is, we have that the cost of capital is equal to the AIRR minus the NPV per unit of invested capital multiplied by 1 plus the first period cost of capital. This is not circular at all. The AIRR is computed from the incomes and the capital amounts. And then we have a ratio. The denominator is computed from the capital amounts, and the numerator is computed from the cash flows, but the cash flows are computed from the incomes and the capital amounts. And then we have the conversion factor. In our example, we have that the cash flows are f of 0 minus 600. It is the capital expenditure, and the cash flow at time 1 is equal to the first income minus the change in capital. And the first income is 375, and the change in capital is 200. So cash flow f of 1 is 575, and the cash flow f of 2 is equal to the difference between the second profit and the change in capital in the period. 225 minus the change in capital, which is minus 400. This makes 625. And so we can write, for our example, that the overall cost of capital, or the minimum attractive rate of return, is equal to the AIRR, which we have already computed as 57.8%, and then we subtract the NPV, and we can write the NPV as minus 600 plus the discounted value of $575. We discount it back by one period at 15%, which is the first period cost of capital, and then we discount $625 by two periods at 15% for the first period and at 30% for the second period. Okay. The total capital, we have already computed it. However, let's compute it again. 600 plus 400 divided by 1.15. We just have to multiply by 1.15, and we get the overall cost of capital. We find back our cost of capital, which is 19.2.